Hello everyone, this is Saurav from Edureka, and today we are going to focus on what are microservices. So without any further ado, let us move forward and have a look at the agenda for today. So these are the topics that we'll be covering today. We'll begin by understanding why we need microservices, right? Everything exists for a reason, so we'll try to figure out why we need microservices, right? Then we'll focus on what is microservice architecture and what are its various features. Then we'll understand various advantages of microservice architecture and we'll look at companies using microservices. And finally, there will be a demo based on microservices in which we'll have three services that will be communicating with each other. So let's move forward, guys, and focus on why we need microservices. So before microservices, we all know that there was an architectural pattern called monolithic architecture that was used. All right. So there are certain disadvantages of that architecture, but let me first explain you that architecture, what exactly monolithic architecture means. So basically, in this, the entire software is composed in a single piece that is designed to be self-contained. So what I mean by that, basically all the components of a monolithic program are interconnected and interdependent. Or in other words, if I have to put it, I'll say that it will give you a tightly coupled software where each component along with its associated components must be present in order to execute or compile the code. So all of these components are actually dependent on each other. So if you notice the definition that is there in front of your screen, it says that monolithic architecture is like a big container, right? Think of it as a big container wherein all the software components of an application are assembled together and tightly packaged, right? So if you notice that there is an example in front of your screen, so there's a server-side application, right, which executes a domain-specific logic. It will retrieve and update data from the database and at the same time populate the HTML views to be sent to the browser. So it is basically a big container, or I can say that it is not divided into small services or not divided into small components. So even these components that are there are pretty tightly coupled, right? So I'll give you a better example of what exactly monolithic architecture is. Let me just move forward. So let us discuss a classic example of an e-commerce website like Amazon or Flipkart. All right. So everyone actually visits these websites quite often. So that's a perfect example to explain you. So let's understand what monolithic architecture exactly means with this example. So as you see that in basic e-commerce application, we have a common option of customer service, right? Product service and cart service, which a customer can access through their browser, right? And when you launch the application, it is deployed as a single monolithic application. There's only one single instance, if you can notice. So we have customer service, product service, and cart service. And when you deploy all these services, it will be basically a single monolithic application. Now, what you can do is in order to scale it, you can run multiple instances of this application behind a load balancer, right? Now, let me discuss few advantages of this application. So first of all, it is very simple to develop, right? As a goal of the development tools and IDs is to support the development of monolithic application, it makes the development really easy and one directional, all right? Now, it's pretty simple to deploy because you have to deploy the executable file at the runtime to launch the application. That executable file can be a WAR file as well. Now it is pretty simple to scale as well because in order to scale your application, all you have to do is run multiple copies of the application behind a load balancer. Now, since everything comes with its pros and cons, monolithic architecture also has few major drawbacks. Let's discuss about them one by one. The first disadvantage is large and complex applications. Now, if you have a large application, or you can say with the increase in size of the application, it becomes really complex to understand and modify such applications, right? And as a result, development slows down and modularity breaks down over time. Moreover, because it can be difficult to understand how to correctly implement a change. And due to that, the quality of code declines over time. Let's see what is the next disadvantage. So the next disadvantage is slow development. So what I mean by that, as the application and the respective teams grow, the application becomes difficult to understand and modify, right? Because it's pretty huge in size and there are multiple teams working on it. So it becomes really difficult to understand and modify. Also, the larger the code base leads to slower ID, which makes the developers less productive. So the code base is pretty large because the entire application is one monolithic application, right? There are not different services present. Now it blocks continuous development. So what I mean by that, a large monolithic application is an obstacle to frequent deployments. Let me tell you how. In order to update one component, you have to redeploy the entire application, which interrupts the background task. So if I have to take the example of the e-commerce website, if I have to update the cart service, I have to redeploy the entire application, which includes the customer service, the product service, all the services, right? So there is also a chance that components that haven't been updated will fail to start correctly, all right, because of many dependency issues or anything, right? And as a result, the risk associated with redeployment increases, which discourages frequent updates. I hope you're getting my point. Let's see what we have next. So the next point is unscalable. I know I've told you that it's pretty easy to scale, but let me tell you what are the disadvantages when it comes to scalability and in terms of monolithic architecture. So each copy of application instance will get access to all of the data, right? Which makes caching less effective and increase memory consumption along with input-output traffic. Also, different application components have different resource requirements. One might be CPU intensive, right? While other might be memory intensive. And with a monolithic architecture, we cannot scale each component independently, right? So if you can see the example that is there in front of your screen. So here we have customer service, product service, and card service. This is one instance, and this is how we are scaling it, right? If I have to increase only the customer service, I have to scale up the customer service. I have to do that for product and card service as well, right? Now it is pretty unreliable as well. Let me tell you how. So because of the tightly coupled components, if one of them goes down, the entire system will fail to run. What I mean by that, if one of my, say, product service fails, that will in turn lead to the downfall of my entire application, right? And because all the modules are running within the same process, a bug in any module can potentially bring down the entire process. Moreover, since all the instances of the application are identical, the bug will impact the availability of the entire application. This makes the monolithic architecture highly unstable and unreliable. The last and the final point is inflexible. So how is it inflexible, guys? With the monolithic architecture, it becomes really difficult to adopt new frameworks and languages. Suppose you have million lines of codes written with XYZ framework. Now, it would be extremely expensive in terms of time as well as cost to rewrite the entire application to use the newer ABC framework, right? Even if that framework was considerably better. And as a result, there is a huge barrier to adopting new technologies. I hope you're getting my point. So why is it very expensive? Because you have written million lines of code in some language. Now you want to use some other language, right? So it becomes really expensive and a time consuming task. And even if the new language or the framework is considerably better, but there's a huge barrier in adopting such new technology. So I hope you have understood the various disadvantages of monolithic architecture. Now is the time to understand what exactly is microservice architecture. Microservices, also known as microservice architecture, is an architectural style that structures an application as a collection of small autonomous services modeled around a business domain. Now, if I have to put it in simpler terms, basically, it is a self-contained process which avails different and unique business capabilities. Now, if you have large applications built using this architectural pattern, it can be broken down to small multiple services which together acts as one large system. But behind the scene, it's a microservice. So what I'm trying to say here is we have multiple services. On all of these services, they don't share the data structure, but they'll be communicating through APIs, right? The major advantage of breaking down the system is now each microservice can focus on only one single business capability, which definitely leads to a better quality and throughput. And it's obviously becomes easy for you to understand when I explain you with a example. Again, I'm going to take the e-commerce site example. Now, if you remember in monolithic architecture, all the components were in a single module. But if you see here with microservice architecture, all the components are divided into separate modules, which communicate with each other using a well-defined interface, usually REST or messaging. Now, the communication between the microservices is a stateless communication where each pair of request and response is an independent transaction. And because of this, microservices can communicate effortlessly. Moreover, in microservice architecture, the data is federated. All right, so let me just break it down for you. Each microservice is responsible for its own data model and data, because of which interaction with each microservice is handled by different instance. Unlike in monolithic architecture, where we had only one instance. Here we have multiple instances for different microservices. So we have three microservices here: customer microservice, product microservice, and cart microservice. Right? Each of them have their own instances. They have their own data model and they have their own data. So this is what exactly microservice architecture is. Now let's dig a bit deep into its architecture and understand what it is. Now, as you can see, in a microservice architecture, services are small, independent, and loosely coupled. So let me just tell you where it is. So these are multiple services, right? So these are pretty small in size and they're independent and loosely coupled. Now, each of these services have a separate code base, which can be managed by a small development team and it is deployed independently, right? So this service will have a code base, this service will have a code base, this service will have a code base. Similarly, all of them will have a code base, which will be not huge in size when you compare it with a monolithic architecture where all of these services are running in one instance. I hope you're getting my point. Now, basically, a team can update an existing service without rebuilding and deploying the entire application. For example, if I have to update this particular service, I don't have to do it for the other services as well. I can just redeploy this service independently. Now, services are responsible for persisting their own data or external state. Internal implementation details of each services are hidden from other services. Moreover, they don't need to share the same technology stack, libraries, or frameworks as well. Right? You're getting my point. So they might not have the same technology or same libraries or the same framework, and they have their own database and things like that. So they are pretty independent from each other. Besides, for the microservices themselves, some other components appear in typical microservice architecture. So let me just discuss that. So the first part is management. So the management component is responsible for placing services on nodes, identifying failures, rebalancing services across nodes, and so forth, right? Then let's talk about service discovery. Now, service discovery, the task of this component is to basically maintain a list of services and which nodes they are located on. It enables service lookup to find the endpoint for a service. Let's talk about API gateway now, right? So API gateway is basically the entry point for clients. So this client won't call all these services directly, right? It will first go to this API gateway, which will forward the call to the appropriate services on the backend, right? If I'm a client, I'll request for this particular service, then I have to call the API gateway, and which will in turn call the service on the backend. Now, the API gateway might aggregate the responses from several services and return the aggregated response. Now, it might be possible, right? A client request from multiple services. So at that time, it will aggregate the results from various services and will return the aggregated response, right? So I hope I am clear with the architecture. Let us focus on what are the features of microservices architecture. The first feature is small focused. So what it means that the aim of microservice architecture is simplicity, you know, so that it can be rewritten and maintained without any extra efforts by the development team, right? That's what I mean by small focused. Then the next point is loosely coupled. So as I've already mentioned multiple times that each microservice is independent of each other and do not need to coordinate as well. This makes the development as well as the deployment real quick, guys, right? So if I have to update a particular service, I'll only update that service. I won't, update the other services, right? So that way deployment becomes really quick. So that's the big advantage. Now let's talk about language neutral. So to be a good microservice, it must be language neutral. So what I mean by that, for example, in an application, few services can be written in Python for fast deployment, whereas few might be written in Java because it's speed and extensive libraries, right? So depends on the microservice, what kind of programming language we are using. So it doesn't really affect the other services, right? Now, bounded context. So it means that each microservice doesn't need to understand the implementation of other microservice. So these are a few features of microservice architecture. Now let's talk about various advantages of microservice architecture. Now, the firstly, independent development. So each microservices can be developed independently where a single development team can build, test, and deploy a service. I think I don't need to explain this much. Independent development means if I have a product service, then I can independently focus on product service where a team of developers are writing code for that particular service, testing it and deploying it. Now, independent deployment means that you can update a service without having to redeploy the entire application. Bug fixes and feature releases are more manageable and less risky as well because you have to focus on one particular service. You have to deploy or update one particular service. You don't have to care about the other services or the entire application as such, right? So next is fault isolation. So it is a very big advantage, guys. Basically, if a service goes down, it won't take the entire application down with it. For example, if my card service goes down, my entire application is largely unaffected. Unlike the monolithic architecture, where if one of my component goes down, the entire application fails to work. Next is mixed technology stack. Because of this feature, teams can pick any technology which fits best for their service, right? And last but not the least, granular scaling, which means that services can be scaled independently. Unlike my monolithic architecture, where I have to deploy multiple instances. So in order to scale, here I can only scale a particular service. If I have to, increase the card service, then I can just scale up the card services instead of scaling up the entire application. So let's move forward. So there are a lot of companies which are using microservices. We have Amazon, Netflix, SoundCloud, Twitter, Uber, PayPal, a lot of companies, right? And why this happens? Because large applications become easier to manage when they're broken down into smaller composable pieces. So without any further delay, let's begin with our hands-on. We'll be using Spring Boot because it provides a way to provide Java applications quickly and simply through an embedded server. And by default, it is version of Tomcat. It will basically eliminate the need of Java EE containers. And with Spring Boot, we can expose components such as REST services independently, exactly as proposed in the microservice architecture that we have just discussed. In any maintenance of the components, we no longer make the redeploy of its consumers. I'll tell you what exactly I mean. What is a consumer? For this lab, we'll use Eclipse, Oxygen, and Maven 3. Now to illustrate the concept of microservice, what we'll do, we'll create 3 Maven projects in this hands-on, and each of them will symbolize backend functionality, or you can say reusable APIs. And one of them held a composition. If I have to put it in simpler way, I will say it will be a consumer of the other two. So one application or one service will be a consumer of the other two services, right? So we'll be creating 3 simple Maven projects that I've already done. I'll just open my Eclipse and show you that. So my first Maven project is basically diagnosis microservice. Then we have doctor microservice and we have patient microservice. So this doctor microservice is the consumer, right? And consumer of the other two microservices, that is patient and a diagnosis. All right. So that is how it is done. Now, if I have to explain one of these services, let me explain you the patient microservice first. So over here, as you can notice that we have a pom.xml file. So basically this pom.xml file will establish all the dependencies, right, before we start coding. The first class that we create, that we call application, will be identical in all 3 projects. And it only works as an initiator to Spring Boot, that we call as Spring Boot application annotation. So that's how it is. If you notice here, we have application.java. So it will be common. Application.java and application configuration.java, the 2 packages that we have created, will be common for all the other microservices as well. So if I show you for doctors as well, so here also we have application.java and application config.java. Similarly, for diagnosis as well, if you notice, we have both application.java and the other things as well. Now we have patient.java and we have patient rest.java, right? So the patient.java, here we have defined all the variables, like, the email ID of the patient, name and things like that. And this patient rest.java will be used to provide the input to the variables. I hope you're getting my point. The patient rest.java is basically to provide the input. And we have this application config class as well, right? The package. So let me tell you why we actually use it. Is basically, it is a resource configuration class, which is basically a resource manager responsible for exposing REST services for application consumers, right? So basically for messaging, right? So the REST service is for messaging and it is a stateless service for application consumers. And we can notice that patient.java and patient rest.java are in the same package, right? Now let me tell you how I've defined the ports here. So all I have to do is right click, go to properties, click on run debug settings. And when I go to arguments, right, so I just have to write -d server.port 8081. So you can see that my patient microservice will be running at a port 8081 when I start it. Let me just start all of these services one by one. So I'll start this first. Just click on run as Spring Boot app. Similarly, right click on this and I'll just run it as Spring Boot app again. And I'll run this also as a Spring Boot app. So it's done now. Let me just open my browser. All right, so this is for port 8081, right? So my port 8081 is for patient. So let me just click over there. Let me reload this page again. So here I have my patient microservice. Similarly, my port 8082 is for diagnosis, right? So here I have the diagnosis microservice. And finally, my port 8083 basically is a consumer. All right, it's a doctor microservice. And in the URL, if you notice, I have written patient ID, right? Diagnosis and consultation, right? So basically, we'll get, this particular patient has been diagnosed with this disease, and this is the consultation, right? So let me just reload this again for you. So I can just go ahead and change the diagnosis as well. I can make this as 2, right? So Rachel has been diagnosed with a different disease now. Similarly, if I make it as 1, she has been diagnosed with viral fever here, right? So that is what the difference is. Basically, this particular microservice is a consumer of the other 2 services, right? So you can even think of it as an e-commerce application. I know it's not of that level, but consider it something like, customers, products, and orders. So this patient microservice will become the order microservice, right? And the other 2 will become customer and products. So this order microservice will be a consumer of the product and customers. Similarly, in this example, we have patient and doctors. We have patient microservice and we have diagnosis microservice, and we also have a doctor microservice, which is actually a consumer of the other 2 services. So by this, we come to the end of this video. Thank you and have a great day.